3.2 reciprocal of quadratic function. What is the quadratic function? X power 2, if f of x is x power 2 minus 2x minus 15, this is quadratic, as you know. The highest power is 2. Reciprocal of that is 1 over x power 2 minus 2x minus 15. And everyone know that the quadratic is a parabola, but the shape of the reciprocal gonna be different. I'm gonna talk about the shape of that. How to graph it. Of course, we have a vertical and we have a horizontal asymptote. First things, I wanna graph 2 over x power 2 minus 4. You wanna talk about the domain, range, asymptote, and intercept, and we're gonna talk about the shape of that, how to graph it. I'm gonna go to a to share a new page with you. Okay, the question is f of x equal to 2 x power 2 minus 4. First things I want to do, I want to find the restrictions for x. Restriction for x. How do we find the restriction for it? You just put the denominator equal to 0, and then you find what? Because in denominator, we cannot have 0 in denominator, right? The factor form, if you put it, so it's going to be x minus 2, x plus 2. You equal it to 0. X minus 2 equal to 0. X plus 2 equal to 0. Then x equal to 2. X equal to negative 2. These are the restriction for x. This is your vertical asymptote. The restriction for x is your vertical asymptote. How about the restriction for y? Again, y value, immediately you look at this. Here is restriction for y. In numerator, you have a fixed value, right? Means this ratio never will be 0. That's why let me just bring the pen, right? That's why the y cannot be 0. Why? Because the numerator is fixed number. So this is the restriction for y. So it's going to be horizontal asymptote. Now, how do we find the y-intercept and x-intercept? For x-intercept, you have to put y equal to 0. So the y equal to what? Instead of the, you have to put y equals to 0. So let me just, instead of the y, we put 0. We already know it's impossible because numerator is fixed, right? This cannot be 0. Numerator is fixed. It's 2. 2 over a number is something, but it cannot be. So we don't have any x-intercept. For y-intercept, you have to put x equal to 0. So here y equal to 2 over 0 minus 4, which is negative 1 over 2. Now, having this information, I want to start graphing it. I put the graph here. We have 2 vertical asymptotes at x2 and negative 2. Say here is negative 2, and here is 2. Horizontal asymptote, this is x equal to -2, and here is x equal to 2. This is your vertical asymptote. For horizontal asymptote, we have y equal to 0. Y equal to 0. This is your horizontal asymptote. And I have y-intercept at -1/2. So if this is -1, this is my y-intercept, right? So to make sure how does the graph look like, I can put a point, some points above and below. Guys, give me a second. Yeah. So I'm gonna put a point above and below this vertical asymptote. So here is good that I try for -3, a point here, and a point here, which is 3, okay? And maybe I can try -1 and 1 here. So let's just try from -3, then -1, then 1, then 3. So if you put -3 for x, what do you get? Is 9. If you put 3 here, 3 power 2 minus 4, 2 is 9 minus 4 is 5. So it's going to be 2/5. That's going to be positive, so it's going to be 2/5. If you put 1, you get, if you put, 1, you get what? 2/3. -2/3. The same thing for 1, you get -2/3. Or if you put 3 for x, you get 2/5. I quickly put these points. If this is 1, let's say the 2/5 is here. And that is there. 2/3 is a little bit, yeah. Is there. Anyway, this is here. See, I connected these 3 points. You know I have to go toward the asymptote, but never touch that. From here, I go toward the asymptote, but never touch it. From this point, I go toward the asymptote from this side, but never touch it. Here, I go toward the asymptote, but never touch it. Because we have asymptote here, just need to go toward the asymptote, but never touch that. Here is asymptote. I go toward the asymptote again and never touch that. You guys understand how to graph this? Brian and Theodore? Brian? Any question? I didn't hear you, Brian. Please turn on your...
No.
Okay, thank you. Domain. Domain is restriction for x. D is equal to x belong to real value. X cannot be what? 2 and -2. These are the restrictions. X cannot be 2 and -2. For the range, x belong to real value. Sorry, y belong to the real value. This is y. Y cannot be 0. I'm gonna do the end behavior. End behavior. Can anyone tell me when x go to positive infinity, what does the y do? Anyone can answer? When x go to positive infinity, what does the y go to? Here, for positive infinity, you have to look here, true, at this end. See the y going toward what number? Just look here. 0, right? I don't know if you're talking to them, but I cannot hear you. X going to negative infinity. You're at this end, right? Y go to, again, 0. Both of them is 0 positive because you're going above. Okay, so guys, can you take a picture and let me know if you have any question, Brian and Theodore, or you're fine?